So we're talking about two ways that we can measure angles, and I've described them for you in the booklet there. We're talking about radian measure and degree measure. Now we're very familiar with degrees. Okay, I think the best way to describe it is like you get a circle, and it's like a big pizza, and you're cutting it into 360 pieces. Okay, where 1 degree would be one piece of pizza. And it is an arbitrary measure. It's not something that's consonant with maths that exists within a mathematical structure. It is something that we could create. Okay, you could define it as 1,000 degrees. All right. And I've said it to a number of you before. The reason they use 360 degrees is because the Babylonians did a base 6 counting system, and that means 360. It's got 24 numbers that go into it, 24 factors. Okay, including all the numbers from 1 to 10 except 7. So it's a very powerful number in terms of multiplying and dividing. So that's where that comes from. It could be 1,000. Okay, so that's what we're familiar with. We're familiar with degrees, all right? And we use this symbol for degrees. So 360 degrees is one rotation. Now we're going to talk about radians, all right? Now if you have a circle, then 1 radian is going to be the measure where the circumference is equal to 1 times the radius. Okay? So the way we're going to describe that angle is 1 intuitively c. Alright? If you were to travel around the circle here, 1 and this distance here is going to be half of a radius at 0.5 r, then the angle there would be 1.5 radians. Okay? Halfway around a circle is 3.14 radians, with an infinite number of decimal places, actually pi radians. And then the whole way around the circle would be 2 pi radians. Okay, so we have 2 pi radians, which is 6.28, is equal to 360 degrees. That, if you were to just keep going with radii around the circle, you're going to end up with 6.28 of them. Very good. Okay, let's get into those examples. So we've got here a conversion chart. If we're going from degrees to radians, we multiply by pi on 180. And if we're going from radians to degrees, we do the opposite, by 180 on pi. So here we're starting with degrees and we want to go to radians. So we follow our chart. We're going to multiply it by pi on top of 180. Now I might just break this down a bit and go, how can we simplify this manually? And then with the other ones, we'll just crunch it in our calculator. So it's important to have these kinds of skills. So what we've got here is we've got a number times a fraction, and the number by itself is always on top of 1. So we've got 75 pi on top of 180. And it can be simplified. So we're going, what number multiplies into both? And we're always looking for what's the highest number that's going to multiply into both. So we might start with 5. Okay, 5 pretty clear. Like if you can't see what the highest factor is, you might be able to see it, but if you can't see what the highest factor is, you can say, well, I know 5 goes into that, because it's got a 5 in it, and I know 5 goes into that, because it's got a 0 in it. So what's that going to be? 5 times, so 5 12s are 60, so that means it's going to be 5 times 15. So I'm going to write it like this to show you what's going on. I've got 5 times 15 pi on top of it, and then how many times is 180? It's going to be 36, I reckon, 36 times 5. And how do I work that out? I'm going, well, 60, so 180 is 60 times 3, right? And 60 is 5 times 12. All right? So then another way we could write it is 5 times 36. Right? 12 times 3 is 36. And then I'm going here, we've got 5 at the top, 5 at the bottom, we can cancel that. So we've got 15 pi on 36, and it's like, well, maybe there's another factor. Maybe we can see another factor here. How about 3? Okay, 3 goes into both of those pretty simply. We could write it as 3 times 5 pi on 3 times 12. The 3 can cancel. And this is as simple as we can get it. Okay, the reason we can't divide it any further, 5 is a prime number. Okay? Now, of course, if you put this in your calculator, this is what it's going to spit out. And that's what we're going to do for the rest of the questions there. That's just how you can do it manually. So, let's crunch the next couple on our calculator. Come on. So we're converting to radians. And so because we're stating it as radians, we should put a C there in our answer to indicate the units that we're talking about, 5 pi on 12. And I will say there as well, quite often, our answers in radians will be expressed in terms of pi, but you may be required to round it to 3 significant figures. So we could put that in our calculator, 5 pi on 12, and press the F to D button. Now it'll pop up like this, but they mean exactly the same thing. And if we press the fraction to decimal button or the surd to decimal button, we're going to get 1.308, and to 3 significant figures that would be 1.31c. So you see, there's a number of ways we can express it. What have I done here? I've performed a process to simplify it, and then I've said, here's our answer. We could express it like that, or if we're going to round it to 3 significant figures, we can express it like that. That 5 on 12 pi, it's just a number. It means 1.31, and our unit is radians. Okay, let's do the next one. We've got 31 times pi on 180. We've got 31 on 180 pi. To 3 significant figures, 0.5410. Now you'll see me do this whenever I'm rounding to significant figures. I'm always going to write 4 figures and then round the last one. That's a 0, so it's not rounding up, it's staying as is. Here, 145, we'll multiply by pi on 180. 145 pi on 180. We've got 29 pi on 36. Okay, or to 3 significant figures, 2.530, which is 2.53. Okay, next we're going to go back the other way. We're going to start with some radians and we're going to convert them to degrees. So we've got 3 pi on 2. We're going to multiply it by 180 on pi. Okay, this one might be a little bit easier for us to carry out manually if we were to do this one manually. What we've got is 3 times pi times 180 at the top on 2 times pi at the bottom. So pi can cancel. We've got 3 times 180, which is 540 and 2, and we'll have 250, 270. So 3 pi on 2 radians, all right, 3 pi on 2 is going to be 270 degrees. It's going to be 3/4 of a revolution. Cool, let's do the next couple in our calculator. We've got pi on 6 times 180 on pi. Okay, that's going to be 30 degrees. And then 2 radians is 114.59. Okay, so notice 4 figures, and we round the last one, 115 degrees. So that's all we are starting with today. Okay, I anticipate this will probably take about 10 minutes, maybe 15 minutes. When you do finish it, I'm actually going to hand out the folio task today. Okay, so you can make a start on it nice and early. The first couple of parts of it, I don't need to say much about it. It's going to be a little bit of revision and sort of recalibrating the stuff we did last term, and so you should be able to get a roll on with that. Okay, but that's our plan for